All right, we're in section 3.4, solving now inequalities using addition or subtraction. The good news is that we solve inequalities much the same way that we solve equations, except now I just have multiple solutions to the inequality. There isn't just one solution like there is with an equation. You'll see more of what I'm talking about in just a minute. All right, first we need to go over just some terms and definitions for inequalities. All right, so an inequality is a statement formed by placing an inequality symbol between two expressions. An inequality symbol is what we see listed below. Less than, greater than, less than or equal to, and greater than or equal to. We see these symbols. Okay, that separate them from each other. Those are what we call inequality symbols. So what is the difference between an equation and an inequality? I want you to look up here just for a second. We see the equation x plus 4 equals 16. We can use mental math and we know that what number is the solution? 12. X equals 12. Can it be any other number? Can it be 11? Would it be true? No. The only number that makes the equation true is the number 12. There is only one solution. But if we take those same terms and we now place an inequality sign here, our answer is still 12, except now, how many numbers do we know of that are less than 12? Give me some examples. 1, 2, negative 4, 10. There is literally an infinite number of numbers that would make this inequality true. Correct? So that's the difference. With an inequality, there's an infinite number of solutions. However, there's a line, okay? And here it's at the 12. If the number goes greater than 12, then the inequality is no longer true. Okay? So that's the difference. You need to learn your inequality symbols. Do you see this line underneath the less than sign? Do you see the line there? Look, you see the line? That means that it's equal to that number. It means that the solution can be that number. That's what the line means. It means that it's equal to as well. All right, hopefully you have everything written down. If you don't, we can come back to it. But now let's look at this chart. I don't think it's the first section, but you have a section in your homework tonight where you see a graph that looks like this, and you're going to have to write it as an inequality. Okay? So I just want to go over basically how these three categories relate to each other. We start by reading the inequality, okay? And we always read the variable first. X is what? Less than 3. What is it saying in words? All numbers less than 3 will be a solution. Name any number less than 3. Give them to me. Negative 2, 1, 0, negative 3,000, okay? Doesn't matter. All numbers less than 3 will be a solution. So over here on the graph, listen, pay attention. Since the solution is not 3, okay, since it's just less than 3, it is an open dot. And my arrow goes left, showing that all the numbers less than 3 are solutions. Same thing goes with the next one. Now it is greater than 2. All numbers greater than 2, so again, it's an open dot on the 2, and the arrow is going right because all solutions are greater than 2. Now, on the last two, what symbol is this? Right here, which one is this? It is what? Less than or equal to. So since it has the equal to component, that bar underneath, my dot will be closed in because it could be that number. The solution could be that number. All numbers less than or equal to -4. Same thing goes with the last one. All numbers greater than or equal to 2, so it's a closed dot on the 2. All right, so that's basically how they look from the expression or the inequality solution to actually graphing it. All right. Now, if you don't have every single one of those things written down, that's okay. It's captured in the recording, and it's also in your books. Okay, so you can see it right there in section 3.4, I believe on page 138. Page 138. All right, so moving on to example 1. I want to read this. It's okay if you didn't get it all. I'll come back to it. All right, let's read it together. It says the freezing point of water is at 0 degrees Celsius. Temperature is at or below the freezing point. Water is solid. Write an inequality that gives the temperatures at which water is solid. All right, so what's my value? What's my number? 0. Okay, and I've got to have a variable. So now I have to figure out what is the inequality that connects them. This temperature, it can be, is it saying that the temperature can be greater than 0 to freeze? Or what do you think? It says temperatures at or below. It's got to be less than, but can it be 0 and still freeze? Yes. So that's why it's equal to. Because that number could be 0 and still freeze. Could it be 1 and still freeze? No, and that would make the inequality false also because 1 is not less than 0. It could be any negative number or it could be 0. So that is the inequality that represents that statement. You have a section like this on your homework tonight where you are going to write an inequality that represents the statement. Okay, so you've got to watch that wording. I want you to try this one. When driving on the highway, the speed limit is 70 miles an hour. Drivers who go faster than 70 or speeding could receive a ticket. Write an inequality that gives the speeds at which drivers can be ticketed. Then graph it. So now we're going to graph this solution after we write the inequality. All right, Jonathan, what'd you write?
X is greater than 70.
X is greater than 70. Now, if you're driving 70, are you technically speeding? No, so that's why it's not equal to, okay? You get a ticket. Now, if you're driving 71, could you get a ticket?
No.
Yeah, you could. Now, would that police officer be kind of a jerk? Well, yeah, for writing you for going 1 over. But technically, you are speeding at that point. All right, so here's how I graph my solution. You'll see more of this in a minute. But we're going to graph these using a number line, just like we just saw. The middle number is going to be whatever number was the solution. In this case, it's 70. Now think of it on a number line. The farther left my positive numbers go, the smaller. So the number directly to the left would be 69, and then 68. The numbers to the right would be 71 and 72. First step is to number my number line. Second step is to decide, is it an open dot or a closed dot? An open dot is just greater than or less than. In this case, that's all that I have. If it's closed, it will have the bar underneath the greater or less than sign. Then it would be a closed dot. Okay? The bar underneath, it has that little line underneath here like this. Then it would be equal to, but it's not. All right, then I read it. Variable first. X is greater than 70. All numbers greater than 70. Well, which way does the arrow go to show that the numbers are greater than? To the right, because these are all numbers that are bigger than 70. Greater than goes to the right, less than goes to the left. And that's how I would graph it. Now look at example 2. Here's the good news. Solving an inequality is the same process as solving an equation. How could I get m by itself? How can I get m by itself on one side? How do I do it? I subtract what? Subtract 5 from both sides. And m not equals. That's a very common mistake. M is greater than or equal to 5. That's my solution. Now I'm going to come down here and I'm going to graph my solution. What's my middle number? 5. It's my solution. What numbers go to the left? 4 and 3. That's all I need is 2 numbers. What numbers go to the right?
6 and 7.
6 and 7. Open or closed dot? Closed because it is equal to. That's why it's closed. Closed dot because it's equal to. And I read the variable first. M is greater than 5. What does that mean? All numbers greater than or equal to 5 will be a solution to this inequality. All right, so we subtract 27 from both sides because we still have to isolate the variable on one side of the inequality. And now we get negative 10 is greater than r. Now, there's 2 things that we have to point out here. The first one is if you do not read the variable first, you will more than likely graph your solution wrong. You have to read it that r is less than negative 10. Here's what I'm saying. All numbers less than negative 10 are the solution. Name me a number less than negative 10. No. Negative 11, negative 12, negative 13. Okay? You've got to read the variable first. So here's how it's graphed. Okay? Negative 10. Now the farther you get from 0, what's this next number to the left?
Negative 11.
Then what? Then on this side it's negative 9 and negative 8. Open or close dot? Left or right? Left. Remember, read the variable first. R is less than negative 10. All numbers less than negative 10. So negative 11, negative 12, negative 13, those are solutions. That's why the arrow goes left. All right, so on the next example, now we're just still solving, but we're just doing these inverse operations, opposite operations. How do I solve for x in the first one? How do I solve for x? Add 12 to both sides. Go ahead and do that and graph your solution. All right, so we add 12 to both sides. Okay, so Eric, to answer your question, if I said 2 is greater than x, then I would graph it in the wrong direction. It's not a greater than sign. All right, it's that x, or all numbers, have to be less than 2 in order to be a solution. Do you see that? All numbers have to be less than 2 in order to be a solution. So when I graph that on my number line, and I graph a 2 here, and a 1 here, and a 0, and a 3, and a 4, is it an open dot or a closed dot? Open. And which way does my arrow go? To the left, because all numbers have to be less than 2. You have to read the variable first. All numbers less than 2 are solutions. All right, look at this next one. You may have already started it. I add 16 to both sides because I have to isolate the variable on one side. And now s is less than or equal to negative 12. Graph your solutions. All right, when we graph the solution, we've got negative 12. What 2 numbers go to the left?
Negative 13, negative 14.
Yes, negative 13, negative 14. The farther I go from 0, the larger the negative. Negative 11, negative 10. You're going to lose the points for the graph if you get the numbering wrong. Open or close dot on negative 12?
Closed.
Closed because it's equal to, and then left or right? It goes to the left because it is less than. All numbers less than or equal to negative 12 would be a solution. One more example. We're going to skip the checkpoint for now. One more example. It says you're competing in a triathlon and you want to beat your time of 85 minutes from last year. So what times can you post in the running event and still beat that time? If you want to beat the time from last year, what inequality would represent that? So we've got our final time over here of 85 minutes. All right, what time? How would I do that? What inequality would represent me beating my time? Think of it in terms of running. My times this year, this combination, 17 plus 45 plus x, does it need to be more than 85? Less than? Can it be equal to? For me to beat it? No, it has to be less than. If it's equal to, then it means I tied my time from last year. Do you see my thinking process there? If I need to beat my time, then it's got to be less than. Now I add my numbers together, and I get 62 plus x is less than 85. Subtract 62 from both sides. And my time, x, has to be less than 23. Less than 23 minutes. What does that mean? It means that if I run 23 minutes, that is 23, right? Yeah. If I run 23 minutes, then I don't beat my time. I have to run it in 22 minutes and however many seconds to beat it. All right, so writing and solving an inequality. If you understand that, that is everything you need to know for 3.4.